Welcome back to Arxflix. Today, we're diving into a fascinating paper titled The Instruction Hierarchy: Training LLMs to Prioritize Privileged Instructions. This research tackles a critical issue in the security of large language models, LLMs, their vulnerability to prompt injections and other adversarial attacks. Imagine an LLM-powered email assistant. An attacker could inject a malicious prompt into the conversation, tricking the model into forwarding all your emails to an unauthorized recipient. This paper argues that the root of this vulnerability lies in LLMs treating all instructions equally, regardless of their source or privilege. This figure illustrates the problem. The LLM receives instructions from various sources, including system prompts from developers, user messages, and tool outputs. The attacker's prompt, disguised as a tool output, overrides the system prompt, leading to the unintended action. To address this, the paper proposes an instruction hierarchy. This hierarchy assigns different levels of privilege to instructions based on their source. System prompts, designed by developers, have the highest privilege, followed by user messages, and finally, third-party content like tool outputs. The key idea is to teach LLMs to prioritize higher privileged instructions when conflicts arise. This means the model should ignore or refuse lower privileged instructions that contradict the higher level ones. To train LLMs to follow this hierarchy, the paper introduces two data generation methods: context synthesis and context ignorance. Context synthesis is used for aligned instructions, where the lower level instruction complements the higher level one. For example, if the system prompt instructs the model to be a car salesman bot, a user request to speak in Spanish would be aligned. Context ignorance is used for misaligned instructions, where the lower level instruction contradicts the higher level one. For example, a user request to ignore previous instructions would be misaligned. The paper evaluates the effectiveness of the instruction hierarchy using various benchmarks, including prompt injection, system message extraction, and jailbreak attacks. This figure shows the impressive results. The model trained with the instruction hierarchy demonstrates significantly improved robustness against various attacks, even for attacks not seen during training. The paper also addresses the concern of over-refusal, where the model might refuse to follow even benign instructions. The results show that the model learns to follow non-conflicting instructions almost as well as the baseline model. This research presents a promising approach to enhance the security of LLMs by introducing an instruction hierarchy. The paper demonstrates the effectiveness of this approach through rigorous evaluation and highlights the potential for further improvements. The authors discuss future directions, including exploring model architecture changes to better incorporate the hierarchy and investigating the generalization of this approach to other modalities like images and audio. This paper offers a valuable contribution to the field of LLM security, paving the way for more robust and reliable AI applications. Thanks for watching Arxflix. Don't forget to like, subscribe, and share this video with your fellow AI enthusiasts. Stay tuned for more exciting research summaries. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.